एडमिन महोदय, चतुर्वेदी सर ने ज्वाइन कर लिया है, आपको होस्ट बनाइए। सादर प्रणाम सर, नमस्कार। मेरी आवाज आप तक पहुंच रही है? नमस्कार सर, आप मुझे सुन पा रहे हैं?
हाँ, बिल्कुल सुन पा रहे हैं। आवाज आ रही है।
जी 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 सर।
आपके
सर,
साथ प्रेजेंटेशन शेयर किया है।
जी जी जी, आया है।
अभी हाँ, इधर से थोड़ा सा मुझे लगता है कि प्रॉब्लम होगी।
जी, मैं सर अपनी तरफ से करवा दूंगा सर।
ठीक है।
जी, एक बार सर वीडियो ऑन करेंगे क्या? टेस्टिंग हो जाएगी सर।
तो वीडियो ऑन है।
अच्छा, ऑन है।
हाँ, ऑन तो है। दिख रहा है आपको?
दिख नहीं रहा एडमिन महोदय, आपको दिख रहा है?
इसमें तो दिखाई दे रहा है।
रोहित सर का वीडियो दिख रहा है आपको?
नो सर।
सर वीडियो नहीं दिख रहा सर।
बट इसमें तो दिखा रहा है। फिर दोबारा करूं?
जी जी, कर लीजिए सर वीडियो सर। पिछले लेक्चर में भी सर जो है नहीं
वो
दिख पाया था।
वो हमें लगता है कुछ इसमें।
जी,
अभी देखिए, एक मिनट। Choose video।
अब
अब
दिख
आया?
गया सर। जी जी
हम्म।
जी, आ गया सर, आ गया।
हाँ,
प्रणाम
कुछ
स्वीकार है सर।
कुछ इशू रहा होगा उसमें।
जी 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 जी, प्रणाम स्वीकार है।
तो कुछ कुछ इशू बने रहते हैं उसमें।
जी 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 जी, कुछ इश्यूज बने रहे। और वैसे ही सर ऑनलाइन पेडागोगी है, हाँ, इसमें टेक्निकल टेक्निकल ग्लिचेस बहुत स्वाभाविक हैं। अब
हम्म।
यदि आप ये चाहें कि कोई व्यक्ति यदि जो है झांसी में मतलब बैठा है और हम उनका अनुभव यदि ग्वालियर में लेना चाहें 110 किलोमीटर पे, थोड़ा बहुत तो झेलना पड़ेगा।
बिल्कुल बिल्कुल, थोड़ा बहुत तो झेलना पड़ेगा। तो वो भी घर में हो, अगर ऑफिस में होता तो भी दिक्कत नहीं थी।
जी जी जी।
ऑफिस में आज कुछ प्रॉब्लम थी तो।
हाँ हाँ, वो इलेक्ट्रिसिटी का सर जो है बता रहे थे आप।
घर में तो इन्वर्टर
हम्म,
से है तो कोई, हमें लगता है दिक्कत नहीं होनी चाहिए। अब देखिए।
नहीं नहीं, हाँ हाँ हाँ, अब तो कोई दिक्कत नहीं है।
अब नहीं होगी दिक्कत, कनेक्ट हो गया।
प्रेजेंटेशन सर दिख रहा है आपको?
हाँ हाँ, बिल्कुल 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 दिख
जी
रहा।
सर, महज 2 मिनट के अंदर हम स्टार्ट करते हैं सर।
ठीक है। ठीक है।
जी।
तो वो जान ही रहा था तो मैंने कहा इसको पीडीएफ को भेज देता हूँ आपके पास।
सेफ साइड ठीक रहता है।
हाँ, क्योंकि
हाँ।
बफरिंग होने लगती है तो दिक्कत होती
हम्म।
है।
जी जी जी। हम्म। राजमाता विजयराजे सिंधिया कृषि विश्वविद्यालय ग्वालियर द्वारा माननीय कुलपति प्रोफेसर अरविंद कुमार शुक्ला साहब के सफल मार्गदर्शन एवं नेतृत्व में आयोजित ट्रेनिंग एग्रीकल्चर इन फ्यूचर एंड फ्यूचर इन एग्रीकल्चर के 17वें दिन मैं आदरणीय प्रोफेसर एस के चतुर्वेदी साहब का 17वें दिन हार्दिक स्वागत करता हूं। आप एक शिक्षाविदी नहीं अपितु हमारे गुरु एवं अभिभावक भी हैं, और मैं ये समझता हूं कि मेरे जैसा किंचित व्यक्ति आप जैसे बृहस्पति समान व्यक्तित्व का गुणानुवादन या ब्रीफ बायोडाटा नहीं पढ़ सकता। जब जब मुझे व्यक्तिगत या मेरे विश्वविद्यालय को, आरवीएस के विवि ग्वालियर को आपके सहयोग, आपके आशीर्वाद की जरूरत रही है, हमेशा आपका सहयोग और आशीर्वाद विश्वविद्यालय को मिलता रहा है। आप इससे पहले रानी लक्ष्मीबाई केंद्रीय कृषि विश्वविद्यालय में बतौर कुलपति भी रहे, आप अधिष्ठाता कृषि संकाय भी रहे, और वर्तमान में अधिष्ठाता शोध आप पदस्थ हैं। अनेकों अंतर्राष्ट्रीय एवं राष्ट्रीय ख्यातिलब्ध जर्नल्स में आपने बहुत सारे पेपर्स प्रकाशित किए हैं, बहुत सारे बुक चैप्टर्स, बुक्स, अनेकों दलहन में यदि प्रजातियों का नाम लिया जाए तो दलहन में एक बहुत बड़े हस्ताक्षर देश में आप माने जाते हैं। वर्तमान में विश्वविद्यालय का प्रतिनिधित्व करते हुए आप मुर्डोक यूनिवर्सिटी ऑस्ट्रेलिया में भी भ्रमण करके आए हैं। तो इतनी सारी उपलब्धियां हैं आपकी, मेरे जैसा महज एक अंकुर, आप जैसे सघन वटवृक्ष का गुणानुवादन नहीं कर सकता, क्योंकि हम तो आपके छांव में जो है पल्लवित पुष्पित फलित हो रहे हैं। इन्हीं सूक्ष्म अभिव्यक्ति के साथ, सूक्ष्म भाषण के साथ या सूक्ष्म बायोडाटा के साथ मैं ज्यादा न समय लेते हुए भी, क्योंकि आपने कहा है कि टेक्निकल ग्लिचेस और वहां से इलेक्ट्रिसिटी का फॉल्ट आ रहा है, मैं सीधे आह्वान करूंगा कि आप कृपया अपने लेक्चर पे आए, और हमारे पार्टिसिपेंट्स बड़ा बेसब्री से आपका इंतजार कर रहे हैं आपको सुनने के लिए।
थैंक यू। Thanks for inviting me to share some of the thoughts. Of course, most of the information I have taken from the Indian Institute of Pulse Research Kanpur, because it relates with the pulses. And for that, thanks to my team back at IIPR Kanpur, since I hail from there only. So a lot of information I could get from Dr. Shailesh Tripathi, Dr. Aditya, Dr. Sanjeev Gupta, who is currently ADG Oilseed Pulses, and also from Dr. Nayak. Because these are the people, those are responsible for collecting information and compilation. So I could get some updates from these people, thanks to all of them. Thanks to Vice Chancellor of the Rajmata Vijayaraje Scindia Agricultural University, and to Dr. Ankur Sharma as well for inviting me. So let's go straight forward that as we know that what is to be done in future. So everybody talks about the future of agriculture, and I am not the exception. So I am also going to talk on the same line. So when we say that pulses for sustainable or sustaining agricultural production based to meet the future food demand, certainly it relates with the two things. First is the area expansion for pulses. That's number one. And second comes the enhancing the production or the productivity of the pulse crops. So production can come either from the area increase or from the productivity increase. Since the easiest thing is to go vertically, means to enhance the productivity, and certainly I will be more depending on the productivity enhancement. Then secondly, of course, I will be touching somewhere the production or the area expansion as well. Next one. Can someone help in rolling the slides?
Sure sir, बिल्कुल sir.
So
आप बस next बोल दीजिए.
Yeah. So overview of the presentation will be something I will be talking about the introductory one, then the historical aspect of the crop breeding, then some achievements, of course, the food grain production and self-sufficiency I will be talking in between. Then the impact of research, breeding technique, summary, all those small things I shall be covering at any point of time. If someone feels to have clarification, people can write in chat box, and at the end I will be happy to respond to all of them. Next one. Yeah. So as we always say that nothing has been done in oilseed and pulses and many other crops. So just to apply our young scientists or the participants, including the students, that no, it is not so. In last 8 to 9 years, spectacular growth in pulses production has been achieved in this country, and now we say there we are almost self-sufficient in case of indigenous pulses production. And this slide particularly, it speaks well. If you say the 2007-8, then something like 15 million ton we were not, it was less than 15 million tons, something like 14.97 million ton in 2007-8. And now in 2021-22, that's the, we have the final figure as well. So continuous improvement is there, and something like 82%, means almost double pulses production has been achieved, and that is mainly due to chickpea, because chickpea production has almost doubled, and same way it has followed the mung bean as well. So contribution of the research, development, and the policy frame of the government of India has contributed a lot towards the spectacular growth in pulses production. Next one. Then if we say that from where this pulses production is coming, so something like 70 to 75% its production is coming only from these 5 states. So Madhya Pradesh is number 1, followed by Maharashtra, Rajasthan, Gujarat, and UP. These are the 5 major states. And of course, Uttar Pradesh and Gujarat, they just move neck to neck. And sometimes Uttar Pradesh is at number 4, then sometimes Gujarat. So these are the 5 major states. And if you look at have a look at the map of the India, then you can say that mostly starting from Uttar Pradesh towards south and west, if you move, then a lot of area under pulses is there. And same way, the production is mostly from these 5 states. Of course, Karnataka, Telangana, part of Andhra Pradesh, Jharkhand, then part of Bihar, part of Haryana. These other 5-6 states, they are also contributing. But majority of the production, almost 75-80% is coming only from these 5 states. Next one. So then certainly question arise that from where this production is coming and why? What are the factors? So I told you that there are 5 states from where more than 70% pulses are being produced. Certainly there must be some reason behind that. So what are those regions? Number of varieties have been released for central and southern India. That's number 1. For these 5 states, a number of varieties have been released, and those varieties have also gone in the seed chain. Same way, the modern crop production technologies, particularly the water management and the nutrient management, integrated pest management. When I say pest management, it includes disease and insect pest both. So we have certainly developed number of varieties. Matching production technologies have been developed. IPM technologies are now available for these states. So certainly these states have contributed a lot. Then the expansion of area of pulses and rice farrow has also taken place. Same way, the mung bean crops like mung bean and urd bean, they have gone in the summer or the spring season or in non-traditional area. When I say that some of the pulses like chickpea and lentil and peas, these 3 crops have gone to rice farrow. How this could happen? Because we could develop very good varieties having heat tolerance. Then second is the crop production technology to and optimize the yield in rice farrow area. So these factors have also contributed. Then over and above, if you say that certainly we were having earlier also we were having very good varieties, seeds were also available, but the main thing has happened during the last 7 to 8 years, means after 2016, the policy frame with the government. We had discussion, and government of India launched several policy issues. They have tackled the managed issues, they have launched the schemes, and those schemes like the minimum support price and assured procurement on that MSP. That's number 1. Number 2, establishment of the 150 seed hub for production of quality seed of newly released varieties. Then as a backup, what they have done? For backup, a different category of centers were created, and those 9 centers were involved. Later became the 14 centers. Those 14 centers remain involved in production of breeder seed of newly released varieties. So these centers became the feeder for the seed hub. So something like 1.4 to 1.5 lakh quintal seed of newly released varieties could be produced in this country. Since this 1.4 to 1.5 lakh quintal seed was produced at the farmer's field, certainly there was involvement of something like 14 to 15,000 farmers. It means in a year, we could train at least 15,000 farmers in quality seed production. We could create the awareness about the newly released varieties. So that has paid the dividend, and now country is almost self-sufficient in case of pulses. Next one. Then just I was talking about the minimum support price. So it won't be right at from my side if I am not sharing this particular slide. Deliberately I have put this slide. Just you see in 2015-16 and you compare the 2023-24. Almost 51% increase in PNP MSP, 52% increase in chickpea MSP. In case of mung beans, 76% increase. Same way it would be in 50%. In case of lentil, which we are importing now in some quantity, same way as the pigeon pea, we have, the government has increased minimum support price from 3,400 to now 6,425 rupees, means something like more than 88% increase in minimum support price has taken place, and that has really encouraged our farmers to grow more pulses with the good agronomic practices. Means earlier farmers were more or less reluctant in ensuring the application of the fertilizers and going for the IPM. Since quality seed was made available, assured procurement was there on MSP, so farmers got encouraged and they started putting irrigation, some quantity of fertilizer, and also started taking care of the insect pests and diseases, and that led in higher production of pulse crop in this country. So what is to be done? If you see, then in India, we were not procuring pulses so earlier, but now government has started procuring indicative pulses, and here you can see that procurement of food grains, oil seeds and pulses. Just I thought, let me compare it. Still, there is only procurement of 5% of the total pulses produced in this country. Last year, this in 22-23, something like 2 million ton of pulses were procured from the farmers. Still, that 2% is also not more than 7%. Whereas what we are doing in case of oil seed, more than 2.3% of the total production is being procured by the government. Same way for rice, 38%. For wheat, 35%. So comparing to rice and wheat, still procurement at MSP of pulses and also of oil seed is at minimum. And pulses is really at minimal, it's hardly 5 to 6%. So now government has launched several schemes with the government, state government to encourage procurement of pulses on MSP. Once that is done, certainly in this country, there won't be any dearth of pulses for future. Next. Yeah. So just to share some of the things about the historical background, because it won't be appropriate if our young researchers and the students, they are not aware of the historical background. So certainly that pulses were important. In the 1960s, we launched first AICRP, that was on maize, and subsequently in 1966-67, AICRP on pulses was also created. When these All India Coordinated Research Project on pulses was launched, then the sharing of germ plant, breeding material with among the AICRP center that is started, and breeding programs moved from merely selection to from the lenticide or simple process to multi-parent crosses, and now very good varieties have emerged. Wide hybridization to broaden the genetic base of selected pulse crop, that has also taken place. Same way, later we have added power of the molecular markers to enhance efficiency of selection from the breeding material, and same way the farmers and consumers preferred traits were also managed with the breeding, and accelerated breeding. Of late, we have started the speed breeding as well. So these are some of the historical background. We moved from 1960 to 2023. So certainly the transgenic, gene editing, all are in picture for pulse crops as well. Next one. So what earlier we were doing, as indicated, that earlier mostly we were successful in ID type breeding. We were just selecting the plant based on the phenotype, but the idiotype breeding could not be started. Of course, idiotype concept came into picture, and many researchers, they started doing it, and later they could succeed, as in case of chickpea. Mechanical harvestable variety means the typically erect type of variety could be developed, after developing the concept of the idiotype breeding. So that has also came into existence. Then the crop breedings were, as I told, mostly it was around the introduction of the germplasm, followed by the acclimatization and selection, and release a variety. Then the purification of landraces following the single branch progeny or the progeny test. So pure line varieties were released. Later, from the simple process varieties were released. Mutation breeding also came into picture, and few varieties from with the help of mutation breeding could be released in this country. And in case of different crops, composites in synthetic hybrids were developed and released, but in pulses. Until recently, hybrids could not be developed for many pulses, but now we have developed hybrids in case of PNP. So now pulses are also in the list of hybrids. Next one. Then these breeding programs, certainly these breeding programs were mucking around the managing the biotic and abiotic stresses, so major diseases, insect pests, nematodes. These were managed. Of late, herbicide tolerance also came into picture to manage the seasonal weeds. Same way among abiotic stresses, drought, waterlogging, then the heat and salinity, the four abiotic stresses remain in focus in breeding programs and also in agronomic manipulations. Then the special characters like the early maturity, high input response, farmers preferred or the consumer preferred traits like extra large seeded chickpeas or the lentils, then the nutri-dense varieties of chickpea or other pulses, then the amenability to combine harvesting that I was talking about to reduce cost of cultivation and to minimize use of agrochemicals also came into picture. Biofortified varieties in case of lentil, IPL 220, then Pusa Gati Masoor. These could be developed. These varieties have high iron and zinc content. Then the chickpea, high protein line variety, IPC 2005-62. It's not 2, it's IPC 2005-62. That could also be developed recently. Next one. Then just to apprise that so far, since the inception of the AICRP and once it became active in this country, something like more than 1,083 varieties we could develop till 2022. Of course, this year again, something like 35 varieties have been released. So if you add, then certainly more than 1,100 varieties have been developed for pulse crops for cultivation in different parts of the country. And more than 310 varieties. These have been released just in last 9 to 10 years. Means since after 2014, more than 310 varieties have been released, and some of these varieties of the various crop I have listed. I don't think that there is any need to read it, but certainly chickpea is at top, where 82 varieties have been developed, followed by pigeon pea, then mung bean, urd bean, lentil pea, cow pea, then horse gram, rajmas. Means these are number of minor pulse crops are there, and for most of these crops, something like 14 crops, we have already developed varieties, and these all varieties are recent one, means they have been developed during last 9 to 10 years. So certainly ample scope is there for utilization of these varieties at the farmer's field. Next one. Then what these varieties have? So these most of these varieties, what they have? They are the early maturing type. Like in case of mung bean, earlier we were having varieties maturing in 70-75 days, but now the varieties like Virat or the Diksha, these varieties can mature just in 55-60 days. Same way in case of lentil, from 140 days to now 120 days varieties are available. In case of chickpea, earlier most of the varieties used to be of 135 days, but with the development of 100 days duration varieties of chickpea, particularly for the southern India, and also for cultivation under late sown condition after harvest of paddy, something like 100-110 days varieties are now available. Same way in case of pigeon pea, number of varieties are coming up. Those can mature in less than 160 days. Same way in field pea, green seeded field pea or the white seeded pea, in both the types we have short duration varieties now available for cultivation in central and southern India, and also in different part of the country in specific agroecological niches. Then in case of chickpea, in Kabul, particularly Kabuli chickpea, extra large seeded Kabuli, like they have in the 55 gram 100 seed weight. In case of lentil, extra large seeded lentil having something like 4 gram plus 100 seed weight. These varieties have been developed, and these varieties have really contributed in export as well. So now almost import of Kabuli chickpea has stopped in this country, and we have become the next exporter of Kabuli chickpea with the development of XLR seeded and medium seed size varieties of ranging from 35 to 55 gram varieties. Now, number of very good varieties at par in yield with desi types are available. Then the yellow mung bean yellow mosaic virus, particularly in case of mung bean and urd bean, these varieties are now available. These varieties have symptoms of maturity and non-settling type. So certainly these varieties are gaining popularity in late Kharif season or also in summer and spring season. Same way the green seeded field pea variety having the farmer's preference and the consumer preference as well for diversified food. IPFD 10-12 that has been developed. So a number of varieties, such varieties have been released in this country, and these varieties are contributing towards improving production and productivity of pulse crops in this country. Next one. Then just I was talking about the hybrid. Of course, the composites, synthetics, or the hybrids, these were not available in case of pulses, but with the invention or with the innovations now, we have the male sterile lines available. So the hybrid breeding has become easy in case of pigeon pea, and we could release, recently we have released 3 hybrids. 2013, that was the first GM+ hybrid that came into picture, and that was restricted to Madhya Pradesh. Later, again in 2015, one hybrid was released, and recently in 2019 and 2020, 2 hybrids have been released by IIPR Kanpur, and these both hybrids are for the northwest plain zone. When I say northwest, means western UP, Rajasthan, Haryana, Punjab. In all these part of the country, we can grow these hybrids, and these hybrids are maturing in less than 140 days. So certainly, after harvest of pigeon pea, farmers can go for crop like wheat. So these hybrids are suitable for the irrigated bed only. Next one. Then same way for the drought tolerance, having the drought tolerance in case of chickpea, at least 5 varieties have been released recently. 2 from IRI, 3 from IRI, 1 from IAPR, and 1 from NIPGR. So at least these 5 varieties are now available, and these varieties are most suitable for the rain-fed condition or for the drought-prone areas of the country. So certainly these varieties will be popular within next 3-4 years, and you will see these varieties will also contribute towards improving the productivity under rain-fed condition and also in drought-prone areas. So certainly more assurance of the area will be there. Next. Then what is to be done when the number of varieties are emerging from different breeding methods? So what is to be done? That we have to ensure the quality seed supply. So how to do that? Now with the advent of the newer methods or the molecular markers, earlier what we were doing, we were using the grow out test to assess the quality, but now variety specific diagnostic molecular markers are also becoming available for some of the crops. Once these will be available, then in no time, means less than 10 days time or 12 days time, one can be say with your assurance about the quality, what type of quality of a particular seed lot has, that can be assessed in less than 10 days. And once that is done, certainly quality assurance will be at place for farmers as well, and farmers with confidence they can grow a particular variety because the quality assurance can be assessed within no time. So what farmers can do, they can just save some seed. Maybe the 100 seed they can keep with them, and if there is any dispute, certainly farmers can go with the agency for the those looking after the quality assurance and can sue the private company or the seller of that particular seed. So certainly quality assurance has to be at place, and at least in case of the seed hubs and the KB cases, these are involved or the NSC. So at least we are maintaining good quality seed, and now something like 2 lakh quintal seeds, good quality seed is available for farmers of the newly released varieties as well. Next one. So before going to the genetic options or the new approaches, here I would like to say that since number of varieties and the agronomic practices and the integrated pest management techniques have been developed for the various pulse crops to manage the diseases, insect pests, or the abiotic stresses in different seasons of major pulse crops. The area of pulses has also increased from 24-25 million ton to 27-28 million ton. Once this area has increased under pulses, it means, as you all are aware, that since the pulses are known for fixing the atmospheric nitrogen through symbiotic nitrogen fixation process to the tune of 60 to 150 kilogram per hectare basis, so certainly this nitrogen is getting fixed in this, and that is being used for the companion crop or the subsequent crop. And with that idea only the intercropping systems are also have been developed in this country. Second important, then since the pulses have the deep-rooted system and number of varieties are now available, having the drought tolerance as well in many crops. So certainly these varieties, newer varieties are also helping in opening up the soil to the deeper strata because they have the deep-rooted system. So the aeration in soil is also becoming more and more. So cultivation of these newly released varieties or the other varieties have help in increasing the more area. If more area is there, then certainly the soil health is improving in that particular area, and that soil will help in future production of in meeting the or the fulfilling the demand of the more crop or the more productivity or more production. So more production of the even the wheat and rice can be sustained only if the soil health is ensured, and inclusion of pulses in any system or in any cereal-based cropping system will help in sustaining the production, agricultural production base. Since soil will be healthy, once soil is healthy, then certainly on that soil, if you cultivate any crop, certainly crop will be healthy and that will produce more. So that's what the role of pulses is there in sustaining agricultural production base. Because number of varieties and agro-techniques have developed and farmers have started adopting those. And instead of the 24-25 million hectare area, now 27-28 million hectare area is under pulses. And I am sure with the kind of research advances are taking place in case of pulses, certainly in years to come, this area under pulses will also increase. And certainly in coming years, we will be able to sustain the agricultural production base. And on that, cereals or the required crops can be grown with higher production and productivity. Next one. So coming to the genetic options, because since the students are also there, so I thought let's go with some of the genetic options we should discuss. Those are the new ones. Next one. Please go ahead. So as we say that since everybody is talking about nowadays the frontier technologies, and what frontier technologies we have for agriculture, certainly with the advent of the molecular markers or with the advances in science in terms of the proteomics, genomics or the omics science, certainly now we are well off, and certainly we can start working on these. And number of centers have started working on development of molecular markers, memory of genes and QTLs conferring the resistance to biotic and abiotic stresses, as I have already shown the achievement. Then the identification of linked markers to major diseases, then the deployment of these molecular markers in real breeding program for the development of varieties. Here there is caution that where we should deploy the molecular markers, or we should go for the genomics enabled plant breeding or the crop breeding, that there is caution. Then it should be molecular markers should be deployed only when selection for a particular trait is difficult from the segregating generation. And for the simple trait, or if you can identify a particular trait that is more based on the morphology or looking at the plant, then certainly there is no need to go for the molecular markers. Why? To increase cost. So there is caution then that for the traits for when the selection is difficult, we should certainly go for the genomics enabled crop improvement. Next one. So how to develop the mapping population? Because you all know that we have to make crosses. Then certainly the crosses, once those are advanced to the segregating in the segregating generation, subsequently, then certainly the families can be selected in later generations, or RIL population like things can be developed, and we can even the F2 or F3 type families, those can be utilized at the for mapping the QTL or the gene of the interest. Same way the BILs are there, RILs are there, NILs are there, double haploids are there. So number of now mapping population are being developed across the centers. So many people have started developing even the NAM and the magic population for mapping and fine mapping of the traits or the genes or the QTLs of the interest. Next. Then certainly just I was talking about that since genetic and QTL mapping is also important, otherwise how to really talk the genetic mapping means using the DNA marker that has to be done. So certainly the genetic and QTL mapping is also important to pinpoint where that particular gene or a particular QTL is associated. Once that is done, then certainly it will be easier for you to maintain or to track the path of the genes or the QTLs being transferred in the breeding programs. So that has to be certainly at place. Next one. Then the genetic transformation or the development or the genetic transformation or the development of the GMOs, genetically modified organisms, that also came into picture. And certainly in case of pulses also, in case of chickpea, particularly in chickpea and pigeon pea, many centers have started genetic transformation. Of course, because of the policy of the government, now this work is going at slow pace. But IIPR, IRI, and there are many centers, those started working on genetic transformation, particularly in case of chickpea and pigeon pea. Of course, RNAi was also utilized, that technique was utilized at IIT Kanpur. So many centers have started for that. Once the policies will be in favor of the GMOs, certainly these some of these researchers will certainly take or they give the advantage to the community. Next one. Since we don't have the favorable policies for the GMOs, because there are many controversies and nobody has to be blamed, because we could not generate the sufficient data also for the promotion of GMOs. So scientists are also partly responsible, and they have to generate biosafety data. Robust biosafety data has to be generated for releasing any transgenic in this country. Now, government has gone with the favorable or the positive policies for release of the genome edited product of the agricultural crops. So many scientists have started working on the genome editing crops. So I am sure that within a few years, you will see the product coming out from the genome editing as well. Next one. Then just I was talking about that the earlier we used to take minimum 8 to 10 years just to develop a variety. But now what we have started doing, many centers in case of pulses have started utilizing the off-season nurseries. Earlier there was only 2 nurseries where we used to grow our material up in Himalaya, that's in Kelong Valley. There used to be a oxygen nursery. Then we developed a nursery in Karnataka and Kathalgiri. But later, IIPR took the lead, and IIPR could successfully develop that oxygen nursery at University of Agricultural Sciences campus in Dharwad, where 2 to 3 generations can be ensured. One generation of the rabi crops, particularly of chickpea, lentil, and peas. One can sow the crop right in the late September. That can be harvested in December. Again, same crop is sown in January. So likewise, minimum 2 to 3 generations can be ensured. So one generation can be in the mainland of maybe in the central India or the northern India. Then just you harvest the crop, and same crop seed can be sown in at US campus, that's Dharwad, and you can harvest. So just that's what I have mentioned. June sowing can be done in June, sowing can be done in July to October, or even late November. So at least 2 to 3 generations can be advanced. These are the under the open field, having some renowned shelter kind of facility, so that one can protect the crop in case of the heavy rains. But taking the clue from this, now scientists have started developing the facilities for rapid generation advancement, where they can go for 4 to 5 generations. So next one. Yeah. So when I say more generation, so when means scientists have given a specific term like the speed breeding. So instead of saying the accelerated genetic breeding population or accelerated generation advancement, now we have started saying speed breeding. So speed breeding is nothing. It is the just the combination of the light and the nutrients and temperature. If these three can be ensured by making having some balance, then crops will be grown in a shorter duration, and then seed to seed cycle was reduced. Then 5 to 6 generation, those can be certainly harvested in a year. If one can harvest 4 to 5 generations, just you can feel that within 1.5 years, we will be able to develop the mapping population, or even the recombinant inbred lines can be developed in only 1.5 years. And if that is done, certainly those material can be evaluated under main season, and in no time, the good elite breeding lines can be selected and seed can be multiplied. So seed cycle, once speed up, then certainly instead of taking the 10 to 12 years, within 5 to 6 years, varieties of different pulse crops can be developed and released in this country. I have given some of the examples how to manipulate and where to manipulate, like the supplemental light is there in the glass house or in greenhouse. Then certainly Rabi pulses like chickpea, lentil and pea, these three crops can be harvested in something like 60 to 70 days only. It means if you can harvest in 60 days, then certainly, or 70 days, then at least 5 to 6 generations can be harvested from it. And with comfortable position, 4 to 5 generations are being harvested at ICRISAT for chickpea. Same way, the supplemental light reduces time required to complete the seed cycle. Taking this clue for the Rabi season, speed breeding facilities have been developed, and for crops like pigeon pea, where shorter light duration is required, means darkness will help. And at ICRISAT, they have already done the experiment. And just further move. Yeah, just move this side. Yeah. So here at ICRISAT, they have developed this dark chambers. You can see the dark black cloths. So what they do, they have reduced the light duration inside this glass house, where we are maintaining humidity, right kind of temperature inside, and we are providing the proper nutrient solution to grow pigeon pea. And this pigeon pea can be harvested also in something like 65-70 days. So they are also going for the 4 to 5 generation cycle, means seed to seed cycle, at least 4 to 5 generations. They can take up in the such type of facility that they have developed at ICRISAT, and now at IIPR and also at IRI, speed breeding facilities for majority of the crops are being developed, and that will be available for the utilization to any breeder working in this country. Next one. Then there certainly, if phenotyping has to be there for the breeding program, so I will discuss in brief about some of the examples of the phenotyping techniques. So go ahead. Next one. Yeah. So what phenotyping says? Now, earlier what we were doing, we were just growing under open field condition and targeted genotypes or the segregating material we were growing, and we were phenotyping for the identification of the donors or for the identification of elite breeding lines for their use in breeding or for their release as a variety. So certainly the plant-based phenotyping used to be there, but now many things have advanced. That's what I thought. Then since advances has taken place over the conventional method, so now the molecular, now the throughput phenotyping techniques are also available, and physiological parameters have also been included in the conventional one. So now based on the morphological physiological traits also phenotyping can be done, and we have also started using the remote sensing or the sensor-based equipment for the phenotyping of the large segregating population or the germplasm accessions. Next one. So just to give a feel, I thought it will be appropriate to talk something about the phenotyping technique. Like for the abiotic stresses for the drought, rain out shelters used to be there. Then some people started using the dry down approach. Then the image-based phenotyping is now at place. Same way for heat. what earlier we were doing, we were just delaying the seeding. And what we were doing, we were exposing pollens to stress under field condition. But now we have started taking pollens from the open field and bring back those pollens in the field of a particular genotype. And under laboratory condition, one can go for the in-depth study for the pollen fertility, stigma receptivity, pollen tube germination, all sort of things can be done in laboratory condition. Then for waterlogging also, particularly in case of pigeon pea, artificial flooding used to be there, but now under controlled environment and creating the situation like the rains, we can go for the screening against waterlogging in case of pigeon pea. In case of biotic stresses like diseases, insect pests, or the weeds, number of techniques have emerged in recent years, and these techniques are really throughput and reliable ones, having the very good efficiency. Then, during last 7-8 years, sensor-based phenotyping techniques, particularly for the diseases, nutrient deficiency, and the soil problems have also been developed. And many researchers in globally, they have started using the newer sensor-based techniques for the throughput phenotyping. Next. So just to have give the feel what really now people are doing, like the crop 3D, that is the largest platform where 3D phenotyping can be assured with the line detection and equipment, and that has also been published. I have given the reference. If someone has interest in the crop 3D, how it works and what has been done, then certainly one can go to this particular reference, and this is downloadable. Anyone can download this particular research article and one can go. Then same way the lysimeter was in use at ICRISAT and also at ICARDA and some other institutions, and this has also become very popular, and for this also I have given a reference below the LysiScan. So if someone has interest in in-depth study, then these two references can serve as a focal point or to start with. Next one. Then the improving heat tolerance, we started working with the physiologists, and the number of genotypes having the high level of tolerance in against the heat stress have been identified in case of chickpea, in case of lentil, and also now in case of field pea and urd bean. Next one. Same way, just I have found that how it works, and pollen-based studies were taken, and here you see both the genotypes. These were shown on the same day, and you see in one genotype you can see the pods are there. In other genotype, only flower buds are there. So because of the high heat or the more heat, that's the more than 35 degrees centigrade, you won't see any pod. Of course, flowers or the flower buds can be there. So that's the kind of genetic variations have been seen in case of chickpea. Next one. So these are some of the advances on heat tolerance screening in case of mung bean and related vigna seed. So a lot of information has been generated at IEPR and at IRI as well. Next one. Go back. Yeah, go back. Just go back. One more. Yeah. So just I was talking about the heat tolerance in case of mung bean. So for mung bean, IRI New Delhi and IIPR Kanpur, they have done a lot of work. Of course, the PIU was pioneer earlier. So many heat-tolerant varieties or the genotypes have been identified, and these varieties or the genotypes are being used for development of the suitable varieties for the spring and summer season for cultivation in entire country. Particularly, empiroscope exists in case of northern India after harvest of potato or after harvest of timely sown wheat. So many varieties are being developed having the heat tolerance in case of mung bean and urd bean as well. Next one. Same way in case of pigeon pea suffers with the waterlogging. Whenever there is heavy downpour, then loss of pigeon pea crop has been seen in northern India particularly, and also in part of the central India. So many centers started working. 5 centers were there, and then IIPR could identify in collaboration with the ICRISAT these 4 genotypes having high level of tolerance against waterlogging, and these pigeon pea genotypes can survive up to 72 hours. These under temporary flooding conditions, these genotypes will survive, and now there is need to identify the genes or QTLs responsible for imparting the waterlogging tolerance in case of PGP. That once that is done, then with the help of molecular markers, certainly those genes or the QTLs of the interest can be transferred to desirable agronomic background. And I am confident that in years to come, varieties having the waterlogging tolerance at least for 48 hours will be available in case of PNP for this country. Next one. Then the same way the new area has emerged because weed problem is unmanageable and many farmers are facing the weed problem. And since the farm laborers, they have become really expensive. More wages are to be paid. So many farmers are not getting labor at the right time when they are required, because most of these laborers are migrating for the industrial towards industry. So the concept of post-emergence herbicide has come up in the case of pulses, because we were having the very good pre-emergence herbicide. Everybody knows about that pendimethalin that is still being used, but there was no post-emergence herbicide available. Then we started working on the post-emergence herbicide tolerance in case of chickpea, and considering the success of the achieved in case of chickpea, in case of lentil, pea, and even in cereal and pulses, many people have started working, and number of donors have been identified. Next one. Same way the pre-harvest sprouting. You all know that once at the time of maturity, if for 2 to 3 days digilling is there, then mung bean, in case of mung bean, that seed starts germinating inside pods only. And that's, we say, the pre-harvest sprouting. So varieties have been screened against that also, and we could identify at least few genotypes where this pre-harvest sprouting is not there, means these genotypes have some level of tolerance, and these potential genotypes can be utilized in further breeding program in case of mung bean as well. Next one. So these are just some of the examples where the advancement has been made in case of particularly the abiotic estasis. For abiotic estasis, deliberately I am not sharing much information, because a lot of information on biotic estasis, like the diseases in insect pest, is already available with in literature. Next one. So to reduce the cost of cultivation, in case of chickpea, we started development of the genotype, typical genotypes you can say in that middle slide, where 2 contrasting parents are there, and the varieties having the typical erect plant type, those are available, and number of varieties have been now released having the erect growth habit, and these varieties are suitable for the combined or the machine harvesting. Then we can increase the population densities as well. We can enhance the resource use efficiency, and these varieties amenable for the mechanical harvesting, since these are the tall ones, erect ones. So these will fit certainly in various intercropping system. And students or the participants, those are from the lentil growing area, particularly of the Tarai belt of the Uttar Pradesh and the Bihar, they can see that even the lentil or the tall type of chickpea is being grown with the sugarcane as the intercrop. So certainly that is there. Then they reduce the dependency on the agrochemicals, particularly the management of the insect pest. You need little bit of or the less amount of insecticide will be required if these typically tall or erect type varieties are popularized or grown at farmer field. So that will certainly help in reducing the cost of cultivation. So this is the new area where many centers have started working, taking the clue from chickpea. So now even in case of PNP, short duration varieties with the short stature are becoming available. And recently IRI has developed one variety that may become popular among the farmers soon, that will be available. Similarly, in case of mung bean and urd bean and pea also, many scientists have started targeting the varieties. Those will be the suitable or the amenable for the machine or the combined harvesting. Next one. In case of chickpea, just I was saying, at least 7 or 8 varieties are now available. And here just I have given the list of the varieties suitable for the combined or the mechanical harvesting. So there is no need to write down, because Dr. Ankur will will be sharing my presentation with all of you. Next one. Then the new area, again to reduce the cost of cultivation. And when the second one, then everybody has started talking about the natural farming or the organic farming. So from the nutrients will come. Considering the future demand of the nutrients for the crops to be grown under natural farming or organic farming condition, we started some work in chickpea and enhancing the nutrient acquisition and use efficiency. So for that, what we have done at Jhansi, at our university, that we have developed the soil resources. So what we have done there, we have developed a small plot where we have grown maize continuously for 4 seasons, and now the phosphorus level in that particular field is less than 5 Olsen P. Means that soil is naturally deficient in case of the phosphorus and also for other crop. And we have just started analyzing the soil, and we have will be growing the chickpea. Of course, at IAPR we started this work, and we could identify contrasting genotypes having the better nutrient acquisition efficiency. Once those contrasting genotypes were identified, certainly scientists working at IAPR have started in-depth study for the causes of those. So these things are coming up, and in years to come, certainly the varieties with better nutrient acquisition efficiency and use efficiency of various pulse crops will be available, and those varieties will be suitable for cultivation under natural farming condition or under organic farming condition without application of much of the fertilizer from external sources. Next one. So that's the preparation for the future. So future strategies for R&D, just I will be sharing some of the salient points. Next one. So some of the areas are important, like the first one I will emphasize. Then there is need for modernization of the pulse breeding program in this country to enhance the genetic gain. That is must. So a number of options are available for that. Number of technologies are available. Already I have spoken about the rapid generation advancement or the speed breeding or the enhancing the increasing selection intensity or the accuracy, then the farm mechanization, automation of the breeding, high throughput phenotyping, precision in field trials, conduct of the field trials, marker assisted breeding, digital data capture, breeding program management. So these are some of the areas where really modernization is required for future. Next. Then the pulses can be promoted as intercrop, and for crop diversification, there is ample scope exists for promotion of the pulses and the intercrop, and something like 2 million hectare area can be brought under the intercrop. Similarly, something like 1 million hectare area can be brought under crop diversification or the crop substitution, where pulses can be promoted. And just I have highlighted some of the areas of Madhya Pradesh, Bihar, and West Bengal, where wheat and barley, because they are the two less remunerative crops. Certainly these crops can be substituted with chickpea. Same with the less remunerative millets or the kharif or the rabi pulses. Millets can be replaced with the kharif and rabi pulses in Karnataka, Maharashtra, coastal area of Andhra Pradesh, and in Tamil Nadu. Even during Rabi season, these can be promoted. Then the replacing rain-fed upland paddy with pigeon pea in Uttar Pradesh, Chhattisgarh, and Jharkhand. MP scope exists for there. Then promotion of Rabi Rajmas in case of northern plains, Eastern UP, Bihar, and West Bengal. And of course, I forgot in case of Maharashtra as well, meaning central India, part of central India also, adjoining area to this Udaipur area of the Kota and Udaipur area of Rajasthan can also be in these areas also we can promote the Rabi Rajmas cultivation, and then certainly at least 2.5 million, 2 to 2.5 million ton of the pulses can be added to the present food basket or the pulse basket of country, and for future we can produce more pulses if we can bring the pulses as the intercrop or also promote as a one of the major component of crop diversification. Once we have started talking about the natural farming or organic farming, certainly without pulses, organic farming or natural farming can't sustain. So certainly I am confident that area under pulses is going to increase. That's the sure. Next one. Then improving productivity of pulse crops. Just I have taken this some information from our ADG, Dr. Sanjeev Gupta, where he has categorically highlighted the yield gaps from India to world. So the productivity has been given in terms of the kg per hectare. So just take the case of chickpea, there is not much scope. The global productivity is 1 ton, and we have already achieved. But if you look at the other countries like Canada, where the productivity is 1.7 ton, so certainly from 1.1 ton, 1.7 ton is huge gap. And if 10% of this gap we can bridge, certainly the productivity of chickpea can be enhanced in this country. And there are options available. Same case in pigeon pea, still gap is there. Same in case of lentil, gap exists. In case of mung bean, there is huge gap. In case of pea, 2.7 quintal is the average productivity, and whereas in case of India, the average productivity is only 1.27 ton. So ample scope exists for promotion of varieties, matching production technologies, matching crop protection technologies. If we can do that, then certainly at least the production can be increased by 3 to 4 million ton without any problem. Next one. And to substantiate this, certainly you see the results from the frontline demonstration being conducted in this country during last few years only. I will say during last 2-3 years. So you see the gap of 20%, 26%, 20%, 23% for various technologies. That gap has been mentioned here. It means on an average 20% productivity can be improved. We can transfer the available technology. When I say available technology, that is none other than the quality seed of yielding recently released varieties, number 1. Number 2, integrated crop management technologies. Number 3 is the integrated pest management technology. Is these 3 we can transfer at the farmer's field, and with the support of the MSP and the right type of remunerative MSP, procurement of remunerative MSP. If these 5-6 things can be ensured, there will be no dearth of pulses in this country, and our farmers can still produce 4 to 5 million ton with the existing area only. Next one. So these are some of the issues, or the how to go, what really country need. So I have highlighted way forward, how to meet the ever-growing demand for pulses for ever-growing population. Since we are mostly vegetarian, so we need pulses in our diet for the cheap protein source. So what is to be done? The per se genetic yield potential has to be increased. Climate resilient crops and their varieties need to be developed. Then the nutrient-dense or the organic food production has to be ensured. Then the varieties for crops amenable for mechanical harvesting, like the combined harvesting, and the cost cutting need to be developed. Rapid generation turnover has to be integrated part of the all breeding programs in this country. Next one. Just to add, pulses remain, and we know that pulses remain the 3rd largest imported agricultural commodity in India after edible wine, fresh food. Still, it means we have to produce a lot. So we have to transfer these technologies, and we have to do research with utmost sincerity to meet the future demand. Then for making the country self-reliance in case of pulses, a sustained increase in production must match with the rising demand. Then the opportunities exist for the accelerating growth of pulses production by developing or promoting climate-smart, high-yielding varieties and innovating matching agronomic practices, where under intercropping system or the new agronomical or the agroclimatic zones to have more area, or to diversify the crop, or to enhance per se productivity in already existing area. Then the pulses should be promoted as commercial crop instead of saying just for the nutrition security. So we should not say that pulses are for the part of the subsistence agriculture. Now there is need to promote pulses as commercial crops. Next one. Then just to summarize, modernization of pulses breeding program is must. Restructuring plant type is must. Managing biotic abiotic stress is must. Intensifying research on new genes in from the wild land disease, that is must. So search has to be done. Then enhancing nutrient acquisition and use efficiency. Then the improving battle productivity, development of the good agronomic practices. Then mainstreaming of nutritional quality traits in pulse breeding has to be there, because now we have almost achieved self-sufficiency. So now this is high time to start for the quality product. That's what the nutritional quality traits need to be considered in all pulse breeding program. Then to cater the need of the plant-based protein market. It's growing like anything. So high protein having varieties need to be developed. Then the quality seed production and supply has to be ensured. If we can do all these, we can, of course, in time to come, we have to manage with this. If we can manage some of the points or the issues in years to come, there won't be any dearth of pulses in this country. With this, I am just thankful to you all. Thank you. Next one. I think it's fine. So a special thanks to all my Pulse team that is based at IAPR and also at the ICR headquarters, particularly Dr. Sanjeev Gupta. So thanks to all our colleagues based at IAPR and also from the RLBCAU, and profuse thanks to Dr. Ankur Sharma and his team for inviting me, and thanks to all participants. If they have any question, they can certainly ask now. Thanks.
आप लोग चैट बॉक्स में लिखिए, चैट बॉक्स में क्वेश्चंस को चैट बॉक्स में लिखिए.
Yeah. So here I am reading there one query that someone wrote that why you stop promoting gram and moong in this year in National Food Security Program. No, we have not stopped promoting chickpea or the moong bean, but since in case of chickpea and moong bean, already newly released varieties, they are becoming popular and seed hubs are taken care of. So we have not stopped the promotion. This is the part of the National Food Security Program very much, and frontline demonstrations have also been allowed for moong bean and chickpea as well. Only thing that since we are importing a lot of urd bean and lentil and pigeon pea from elsewhere, so more emphasis has been given for promotion of technology in case of lentil, urd bean and pigeon pea, because we have to meet the demand wherever we are investing. So we have to reduce the drain of the foreign exchange. That's what government policy is there. So by this way, we can save the precious foreign exchange that is being diverted for the import of these three pulse crops. That's all. Then the difference between resistance, tolerance, immunity, and given classical example. Very good. So when we say immunity, all living organisms, they have to suffer through biotic stresses or the abiotic stresses. So nothing is like immunity. You can't have immunity with the living organism. So immunity is just a term where having the genes or the genes are not allowing even the contact. Okay, so they are restricting the entry. Then comes the resistance. So resistance, again a related term where the host pathogen interaction will be there, but there won't be economic loss. Third degree comes in the queue, moderate resistance, or sometimes we say tolerance. Tolerance means damage will be there, losses will be there, but not to the tune of the economic losses. Those can be managed. So we also say tolerance. So these are the different terms being used to define the level of resistance available or the defense mechanism exists in a particular variety on a particular crop plant. So these are the relative terms with respect to the intensity or the incidence. Yeah. Up to what extent speed breeding is beneficial than field level breeding? Yeah. So certainly speed breeding, as I indicated, let's say the example of chickpea. How many crops can be grown in a year? One crop in main season, that's the Rabi season. If you are seeding sometimes in October, so one crop will be harvested by March. Other crop in our country that can be planted either on uphills or in the area where during summer, where summers are cool. So maximum 2 crops can be harvested for the crops like chickpea, lentil and peas. But if you can manage with the photo period, you can manipulate the temperature, you can ensure the supply of nutrients, then from seed to seed, means crop can be harvested in 60 to 65 days. It means in 365 days, if you divide by 6, at least 6 generations. That's what I said, 5 to 6 generations, depending on the crop nature, like the for chickpea, 5 to 6 generations can be harvested in a year. It means within 2 years, where breeding material will be fixed. Once that material is fixed, from 3rd year, one can start selection of the elite breeding lines, seed multiplication can take place, and further there is testing system for 3 years. It means total, it won't take more than 6 to 7 years to release a variety if someone is utilizing facilities of speed breeding. So instead of developing or releasing a variety in 11 to 12 years, here time reduced to almost half. That's the advantage of going with the speed breeding, number 1. Number 2, development of mapping population, that also takes minimum 6 to 7 years, and here within 1.5 years, one can, or less than 2 years time, one can develop the mapping population also for the purpose of mapping QTLs or the genes of interest. So these are the 2 biggest advantages of speed breeding. Then how we are importing pulses even recent past, how will be self-reliant. Look, population is increasing. You can't increase the area. And then there are some compulsions, means we have the trade relations. So under those compulsory trade relations also, we are importing some pulses. If we are importing, let's say we are importing urdhveen, we are importing lentil, we are also importing pigeon pea, but we are exporting pea, now we are exporting chickpea in large quantity. So we were not even the near to self-reliant, but from 16 million ton, now we are producing 26, 27 million ton. During last 10 years only this has taken place. So certainly in years to come, more pulses will be produced. That's what I said. There is need to substitute crop. Wherever productivity of wheat is low, or barley is low, or rice is low, certainly in those areas we need to promote pulses. Once those pulses are promoted, certainly more pulses will be available. Similarly, as an intercrop, pulses have vast potential. In case of sugarcane, autumn planted sugarcane, particularly rabi pulses like chickpea and lentil can be promoted. In case of normal sugarcane planting, during spring season or during summer season, certainly we can plant mung bean or urd bean. So scope exists even for the promotion of pulse crop during both the season, let it be the Rabi season or the Kharif season or the spring summer season. In all 3-4 seasons, pulses can be promoted as intercropping, means you can bring more area under pulses once that area is more. I said there's something like 2 million hectare can be brought under intercrop without much effort. Certainly more than 2 million ton pulses can be produced. So certainly there are various means to achieve the self-sufficiency and to sustain the self-reliance. In case of pulses, scope exists and government is fully aware of that, and that's what many that MSP for the pulses is increasing day by day. Yeah. Then there is some pulses variety which is suitable under CSG 8962. Those who are familiar with the chickpea, Karnal Chana one is a variety that is very good for the salt affected soils of the part of Haryana, part of western Uttar Pradesh, central Uttar Pradesh, and also part of Rajasthan. That variety can be cultivated. Then gene edited variety. Certainly, it will take time. It is considered for organic cultivation. Nobody has restricted for organic cultivation that you should go for the whether a genome edited variety, whether a high yielding varieties having the climate resistant characters. Certainly, there is no ban under organic farming also that varieties, those gene edited varieties can be grown. There is no. As GMOs are not considered for organic export because the demand is not there, and we are not the GMO cultivating country. We don't have GMOs in our country released, but government has enabled new policies where genome edited products as a variety can be released in this country, and it will take some time, and if market is developed, certainly these varieties will see the light of the day and farmers will start growing because these varieties are safe. And still many countries, they are not allowing import of the GMOs. That's what our country is also not producing. Why to produce is there is no taker. Then, yeah, I think it's fine. Yeah. If no more question, it's fine. Thank you.
जी सर, बहुत बहुत धन्यवाद। मेरे आह्वान पर आपने ज्वाइन किया। जो डाउट्स थे पार्टिसिपेंट्स को, उनको आपने जो है सॉल्व किया। बहुत बहुत धन्यवाद। उम्मीद करूंगा कि मुझे और विश्वविद्यालय दोनों को आपका आशीर्वाद और स्नेह इसी तरीके से मिलता रहेगा।
धन्यवाद।
जी, प्रणाम सर, गुड नाइट।